of n moles of monatomic gas which undergo a thermodynamic process where alpha is some constant. It can be. Okay, the condition is what he has put. What do you mean by molar heat capacity? Okay, let's go back to the calorimetry we have started. So already for a gases, I'll supply Q amount of heat. It was having temperature T1. After some time, on observing heat Q, it will attain a temperature T2. Okay, what is Q is equal to number of moles N. This is C, no? C delta T, you write it. And this molar capacity, you can define N delta T. Okay, let's do one thing. Molar different process, no? So first different process, then what will happen to molar capacity? First isothermal process. Let me start from here. In isothermal process, what is delta T? Zero, no? Delta T will be zero. If delta T is zero, then molar capacity, how much? It will become infinite. Adiabatic process. In adiabatic process, the Q itself is zero. If Q zero, molar capacity will be zero. What do you mean by molar capacity infinity? It can absorb any amount of heat. What do you mean by zero? It cannot absorb heat. Then isobar. Isobaric process, Q is non-zero, delta U is non-zero. So Q, what you can write? Delta U plus W. When you solve it, no, you'll end up with CP. Isochoric. Isochoric process. In the same, C will become Cv. Look at this now. So for a given gas, for a given gas, so don't think that this is some gas, this is some gas. A given gas only, depending upon the conditions what we set up, it will have different molar capacity. Altogether, this molar capacity, its value ranges from minus infinity to plus infinity. In general, the value of C varies from minus infinity to plus infinity. What do you mean by negative? What do you mean by positive? Positive means if it absorbs heat, temperature will increase. C negative means if it absorbs heat, temperature decreases. As the gas will behave like that also. Not possible in liquids or gases. Not possible in liquid gases, but it can happen here. If it absorbs heat, C positive means absorbs heat, temperature increases. C negative means absorbs heat, temperature decreases. Okay, no, so these are the basic idea of the molar capacity. Means now, so shall I say that molar capacity depends upon the what type of process it will undergo. If it undergoes isothermal, it will have infinite value. Adiabatic process, zero. Isobaric CP. The same C will become that value. Some other, so for monatomic gas, so CP is how much? 5R by 2. CV is 3R by 2. Diatomic gas, again, will have different values. So therefore, what shall we put it here now? For a given gas, it can have any value from minus infinity to plus infinity. It all depends upon what process it will undergo. We know only this 4 basic process I have given. Now, is it a basic process? No, it is some other process. So we have to calculate what about the molar capacity. Okay, everywhere I'll be using this particular formula. Getting some method, this one. So that's why the gases are used in application. So you might have studied in chemistry why gases are given so important than liquid solids, because the gas what will happen, I can make them to undergo any process, but liquids and solids will not permit. That's why the engineer will allow to Why C is positive negative means it all depends upon situation, ma. You should not ask why in science. Huh? Why refrigerator is there in your home means what you say. For some application, yes. For some applications, I need C negative. For some applications, I need C positive. Okay, now let's get into, we have to calculate molar capacity for such a process. See, we know for isothermal process. Are you seeing? We know for adiabatic process. Similarly, for this process, what is molar capacity? Is it isothermal? Is it adiabatic? Is it isobaric? Is it isochronic? No, general thermodynamic process here. For all general thermodynamic process, there's a formula. So what is the thing? Ideal gas equation, there's a definition, C equal to Q N delta T. Or what I'll do is, I'll go for first law of thermodynamics. So these are the ideal gas equation, molar capacity definition, first law of thermodynamics. These are the things which I'll be using to solve today all the problems what all we encounter. Okay, let's do one thing. First, we'll calculate the work done, because the temperature is what I'm going to change from T1 to T2, which will undergo in a process P equal to alpha V. Let the temperature of gas change from T1 to T2, or let it vary by an amount delta T. In any process, what is work done? In any process, work done is integral of P dV alpha V dV. The temperature of gas is varying. Okay, this will become alpha V square by 2 T1 T2 minus T1 it is. Upper limit. So the temperature of gas is what? A quantity which I can very easily let it change. But can we apply the limits? Yes, no problem. So again, I'll use ideal gas equation. Alpha V square, no? P equal to PV equal to nRT. So can I now substitute? Let me substitute alpha V. So therefore, alpha V square, what you can write? nRT. This I'm going to substitute here. Let n equal to 1 mole, we'll take it. It'll be easy for us. So alpha V square, what we can write now? RT by 2, RT by 2. So T1 minus T2. So what is work done by the gas will be R by 2, T2 minus T1. We know change in intensity. What is change in intensity? Number of moles, we took 1, no? So CV T2 minus T1. Okay, let's come for the definition. What is C equal to? Qn delta T. Number of moles, I picked up 1. What is Q equal to in first law of thermodynamics? So delta U by delta T, W by delta T. Delta T is what? Change in temperature. Okay, delta U by delta T, you can write it as CV. W by delta T, you can write it as R by 2. For monoatomic gas, what is the value of CV? Monoatomic is telling CV is 3R by 2. So substitute this. So molar heat capacity for a process which will undergo P equal to alpha V. Pressure varies linearly is given by this particular formula. Is it isothermal process? No, some process. Let's not bother. What is the molar capacity will be this much here. Getting some. So I think it's a very generalized thing. You need not to bother anything very big here. I'll scroll down. Let me take to the next problem. Just see once the same method what happened will be using almost in several problems. The same idea.